Oh, well, welcome back, everyone. We're going to continue to talk around this idea of exponents, right? Again, this form of multiplication. It's a little bit different, so it's not as straightforward as we talked about in the first video. And we're going to talk about really how we can combine these two, this understanding of like using a power of 10 or a base number of 10 in a way of multiplying. And this comes down to really thinking about efficiency. The examples we talked about in the last video, just to warm up and think, remember an exponent, right, is written with a base number, and then it has its tiny little exponent next to it, and that's really how many times we see that base number. We've been working with a base number of 10 only right now to get ourselves going. So again, if I have a base number of 10 and it is to the power of 5, like that's how we say that, 10 to the power of 5. What that is telling me is my base number 10, I'm writing it 5 times. 1, 2, 3, 4, 5, right? And this is the expanded form because what we're doing is we're multiplying it each time. So we're multiplying that number by itself 5 times. So this is the expanded form. And if we did that math, this is why we're using tens just to begin with. We know that if we just multiplied 1 times 1 times 1 times 1, we would still get 1, and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So we get an answer of 100,000. The shortcut we learned, right, instead of going expanded, is that if I look at my exponential form, that's this one. Remember, this one is standard. That's what we're learning. If I look at that form, the exponent actually tells me when my base number is 10. Sorry, that's like the key part. This only works with you have a base number of 10. But the exponent tells me how many zeros are going to show up. So it's just going to be my 1 with that many zeros. So that's what we talked about in the first video. Today, we're going to take this to another level and really think about this idea of like what occurs when, let's say we have a number like 38 and we're multiplying that by a power of 10, right? So this is something that we would see. This is 10 times, or excuse me, 38 times 10 to the power of 3. Now we do it this way because it's just about efficiency, because we know that that exponent represents a number of zeros. So we can just write it this way instead of writing out the larger number if we desire. But of course, to help us solve it, I would actually recommend that we do write this out in standard form. And so we know that if I have a base number of 10, it's just going to be 1 and then 3 zeros. So 1, 2, 3. And then I can do this work because, again, I'm just using the identity property of multiplication. 38 times 1 is 38. And then I can just count my place values. There's 3 of them because it's the thousands place. So 1, 2, 3 to get 1,000. So my answer of 38 times 10 to the power of 3 will give me 38,000. Right. So that's what today is about, is like now that we understand what these exponents are, how do we use them in multiplication? So let's do another one, whatever, 527 times 10 to the 6. This is going to be a big number. Okay, so again, right, we're going to talk about like what this means, and then we're going to start doing some shortcuts. But if I break this down, this number stays the same because there's really nothing for me to do with it. And then here I could write this in standard form, which is going to be my 1 and then 6 zeros. 1, 2, 3, 4, 5, 6. And again, well, that's 1 million. Wow. Again, we know that because 10 to the power of 6 written in expanded form is the base number 10 6 times. 1, 2, 3, 4, 5, 6. And we're multiplying it each time. And again, identity property of multiplication states 1 times any number is that number. So it doesn't matter how many ones I have, I'm still going to get 1. And then I have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. So again, there's just the relationship between what we're doing there. So it makes sense. But now if I go back to solving this, right? Well, same rule. the identity property of multiplication. 527 times 1 is 527. And then I know with this exponent, which gave me 6 zeros, I would need 6 after it. 1, 2, 3, 1, 2, 3. So 527 million. So 527 times 10 to the power of 6 equals 527 million. So there's the super shortcut now that we can see, right? Instead of writing it out in standard form or expanded form to help me multiply, let's just think about what we know, right? If I have 53, I don't know, I'm just making something up, times 10 to the power of 2. Okay, well, look at the shortcut. 53 times 1 is 53. And this means there's 2 zeros. So I need 2 zeros. 5,030. Or 5,300, excuse me. Yeah. Okay, so we can just continue this trend over and over again. 129 times 10 to the 4th. Okay, well, again, 129 times 1 is 129. And then there's 4 zeros. 1, 2, 3, 4. So that is 1,290,000. Okay, so that's what this work is all about. You know, we often might see other things where we might have 30 times 10 to the 4th times 5, right? Getting 3 numbers that we multiply, and really this doesn't break apart the steps here and kind of do what you know, like make sense of things. So let's see, what could I do first? Maybe actually I'm going to multiply these two first, because 3 times 5 is 15. And then there's 1 0. And then I know that this number times 1 is still that number. So then I would just need 4 zeros. 1, 2, 3, 4. So 1, 2, 3, right? So that's where, like, if we're ever multiplying 3 numbers, is like put together the numbers that you know and then multiply it by base 10 at the end, right? Like it's just breaking things apart. Let's do another one. What if we said 12 times 5 times 10 to the 5th power? Okay. Well, I know that 12 times 5, let's see, I could count by 5 12 times, or I could also just say, oh, this is a 10, that's a 2, so 5 times 2, right? 5 times 2 equals 10, and then times 10 equals 50. Okay, so this would equal 60. 5 times 12 is 60. And then if I did 60 times 10 to the power of 1, well, 1 times 60 is 60, or to the power of 5, excuse me, 10. Okay, 1 times 6 is, oh my gosh, starting over. 1 times 60 is still 60, so I don't have to change my number. And then the exponent tells us there's 5 zeros. So 1, 2, 3, 4, 5. So that'd be 6 million. So that's it. That's what we're doing. How do we solve these problems? How do we work on this? And it's just building on our prior knowledge of what we know about exponents to help us solve more complex multiplication problems. Give this a go. Ask questions until things make sense. As always, thank you for your hard work, and we'll see you next time.